Okay, let's dive into this. Have you ever wondered how really complex systems are built from just a few simple parts? Well, that's exactly what we're going to explore today, but in the world of math. We're going to see how we can take basic functions and combine them to build something way more powerful. But before we get into all the nuts and bolts, let's start with a little puzzle. Think about any company out there. Doesn't matter if it's a corner coffee shop or a huge tech company. What if I told you their entire success or failure could be boiled down to a single, really simple mathematical equation? And here it is. Profit equals revenue minus cost. You've probably seen this a million times, right? But look a little closer. Revenue is one function. It's all the money coming in. Cost is another function, all the money going out. And by just subtracting one from the other, you create a brand new, super important function, profit. See, you're already a pro at combining functions and you didn't even know it. So let's officially break down the tools you have to work with. Just like with regular numbers, we have 4 basic things we can do with functions. Think of this as your essential math toolkit. Now, don't let the fancy notation here scare you off. The idea is actually incredibly simple. To get the sum of 2 functions, you just add them. For the difference, you subtract. Product, you multiply. And for the quotient, you divide. It's really the same arithmetic you've been doing your whole life. We're just applying it to functions now. Okay, but whenever you create something new, you've got to know the rules, right? You need to know which inputs are actually allowed. And this brings us to a really crucial idea, the domain. It's all about playing by the rules of the game. So what exactly is the domain? The best way to think about it is like a guest list for your function. It is the complete set of all the x values that you're allowed to plug in. Some numbers are totally fine, but others might show up and break the math. The domain just tells you who's on the list. Now, for adding, subtracting, and multiplying, the rule is pretty straightforward. The domain of your new function is just where the domains of the original 2 functions overlap. Simple enough. But, and this is a big one, for division, we have a critical exception. We still start with that overlapping domain, but we have to kick someone off the guest list. We have to exclude any x value that makes the bottom of our fraction, the denominator, equal to 0. You know the golden rule of math. You can never, ever divide by 0. All right, we've got theory, we've got the rules. I think it's time to take these ideas out for a spin. Let's get our hands dirty with a practical test drive and see how this actually works. So let's say we've built our new function, and now we want to find its value for a specific number. You know, what happens when x equals 2? How do we figure that out? It's really as easy as 1, 2, 3. First, you just write out the combined function based on the operation. Add, subtract, whatever. Second, you go through and replace every single x with the number you were given. And third, you just do the math. You solve the simple arithmetic to get your final answer. Okay, there's one last piece of the puzzle we need to cover. After doing all this work, combining and creating things, how can we be sure that what we ended up with is even a function in the first place? Well, for that, we have this awesome, super simple visual check. Imagine someone just shows you a graph, right? Just a random curve on a grid. Is there a way you could know, just by looking at it for a second, whether it's a true function or not? Oh yeah, for sure. It's called the vertical line test, and it is hands down one of the easiest, most elegant little tricks in all of math. It gives you a clear yes or no answer instantly. Here's how it works. Imagine you have a vertical line, like a ruler held straight up and down, and you just sweep it across the graph. If that line only ever touches the curve at one single point at a time, no matter where you are, then boom, it passes. It's a function. This parabola right here is a perfect example. But if you can find even one single spot where that vertical line hits the graph in more than one place at the same time, it fails. It is not a function. And this is why a circle isn't a function. See how a vertical line can slice right through it in 2 spots? That's the fail condition. So there we have it. We started with a simple business idea and went all the way to a visual test for graphs. The biggest thing to take away from all this is that you now have this powerful new ability to take simple building blocks and construct and understand much more complex functions. And that kind of leaves us with one final thought, doesn't it? We used a business example, but think bigger. What other complicated systems out there, in economics, physics, maybe even biology, could we understand a whole lot better if we just figured out how to break them down into their simple combined functions?